All right, the next thing we're going to talk about is the long-run behavior of power functions. Now, what do we mean by long-run behavior? What we are talking about when we talk about long-run behavior is how does the function behave in the long run as x gets bigger and bigger and bigger and bigger, as it approaches infinity. All right, what's happening to the function in the long run? Now we could also go in the other direction. A long run in the negative direction would be x getting more and more and more and more negative. All right, so we could look at the long run behavior in both directions. And this brings us to the idea of a limit. So the way that we write x approaching infinity, right here, x approaches infinity, is in mathematical notation, we use this x and we use an arrow, and then this is the symbol for an infinity. It means like a sideways 8, right? So this means x approaches infinity, and it's talking about, x getting larger and larger and larger and larger and larger and larger. So if we look at this function x squared, you can see that as x gets larger and larger, as x approaches infinity, the function, the value of the function also gets bigger and bigger, right? So the value of the function f of x also approaches infinity, right? As x gets larger and larger, okay? And so since the function is x squared, we can write this. We can write that the limit as x approaches infinity of x squared is infinity, okay? This is just looking at how does x squared behave as x gets larger and larger, and it gets larger and larger too. So we just say that the limit as x approaches infinity of x squared is infinity. All right. Now we can also look at what happens when we go in the negative direction, right? As x approaches negative infinity. Now it also looks like, let's see, can I write this? I'll just write it this way. F of x goes to negative infinity, right? Not negative infinity. No, it's getting larger and larger as well. It doesn't ever become negative. So we take a number and we square it, it becomes positive, and we take numbers that are more and more negative, right? Bigger and bigger negative numbers. And we square them and they just get bigger and bigger, but they're going to be positive, right? So in this case, we say as x approaches negative infinity, the function x squared goes to infinity, right? It's the same, it approaches positive infinity, just the same as what happened when x got bigger and bigger in the positive direction. All right, so that kind of introduces the idea of a limit notation and the idea of end behavior. And so we can do the same thing. Here's x cubed. And in this case, you can see that as x gets larger and larger, f of x goes to positive infinity again. But in this case, as x gets more and more negative, f of x goes to negative infinity. All right, negative infinity. All right, that's a negative infinity. All right, because it becomes more and more negative. All right, so that's the idea of long-run behavior. And we're going to take a look here in example 2 at some functions with some similarities. All right, we're going to look at the functions x squared and x to the 4th and x to the 6th. So they're all even powers of x. And then we're going to look at the same thing, only we're going to look at odd powers of x. So I think what might be the best thing to do is take a look at these functions in Desmos. All right, so here I have graphed those 3 functions in Desmos. All right, so I have x squared, x to the 4th, and x to the 6th. And you can see that they all have the same general U shape. Now they're a little bit different. Obviously, the one in red here is x squared. It has a little more curve to it. As the power gets larger and larger, you can see that it flattens out more here at the bottom. But they all have the same general U shape to them. And you could put in more even powers of let's do x to the 8th power, and so you can see it again has that same general shape. All right. The thing we're talking about here is end behavior, and you can see they all have the same end behavior, right? As x goes to infinity, as x gets larger and larger, the function goes to infinity. And the same way as if x goes to negative infinity, the function goes to positive infinity. All right. So that's the main point here. Now we can kind of sketch what we saw in Desmos. If I just quickly sketch, an x and a y axis here, and I just want the general shape. I don't want to get fussy with my sketches, but that's x squared, and then let's say I change color, and then we have like x to the fourth, is a little bit more square on the bottom, but that's the general shape of it. So let's take a look actually down here. I'm going to do the C before I do B. I want to use limit notation to describe the long run behavior. And so I can just say that the limit as x approaches infinity of f of x, where if f of x is a power, an even power function, so it has a power, the power of x is an even integer, right? That goes to infinity. And the same way if we go to negative infinity. So as x goes to negative infinity, right, then f of x also goes to infinity. Okay. All right. So the next thing I want to do is look at the odd powers of x. So x to the third, x to the fifth, and x to the seventh. So I'm going to bring up Desmos again. All right, so here I've graphed x to the third, x to the fifth, and x to the seventh in Desmos. And you can see again that they have a very similar shape. In particular, the long run behavior of these functions, right? Because as x goes to positive infinity, the function goes to positive infinity. And if we go in the negative direction, as x goes more and more negative, right? As x goes to negative infinity, the functions go to negative infinity. So let's sort of summarize what we just found. I'm going to sketch the graph, just a general sketch just of the shape of the graph. And so we saw x cubed kind of looks like that. Whoops, I don't know. Let me make that a little better. Kind of flattens a little more here. That was maybe x cubed. And then if we looked at maybe x to the fifth, it maybe is a little flatter here, but it looks something like that. Okay, so this is my y-axis and this is my x-axis, and that's just the general shape of the function. But they have the same end behavior, right? So let's describe the end behavior down here. So we can say that the limit as x goes to infinity of f of x is equal to infinity, positive infinity. All right. And then the limit of f of x as x goes to negative infinity. Now this time, it's the value of the function is going more and more negative. So we say that the limit is negative infinity. Okay, this is supposed to be like an 8. Sometimes my infinities look like a double zero, but it's supposed to be a sideways 8. All right, that's the symbol for infinity. All right, so that takes care of, that's just looking at end behavior for those even powers of x and the odd powers of x. So I will meet you in the next video for another quick example.